All right, so we're going to start here, and this is kind of where we're transitioning. We've learned about arc measurements in degrees, like when we were talking about, so the degree measure of an arc is the same as the degree measure of the central angle that intercepts the arc. So when we know that central angle measure, we know what the arc measure is in degrees as well. Now, that makes sense because arcs are lengths, or they're parts of a circle that represent a part of a 360-degree circle. Okay, so by talking about degrees, we could talk about the part of that circle that we are measuring. The other way we can measure it, though, because a circle's not just like a pie shape, a circle is also a string that's in a circular shape. So it's also a length that's going in a circular shape. And the way we're going to do that is the length of an arc is the distance between the two endpoints along the circle. If we're going to find out, we're going to learn how to measure it that way. Okay. It'd be the equivalent of having like a curved ruler going around a circle. Okay.
Well, that doesn't matter.
Well, protractor is good for measuring angles. Not as much, it would look like a protractor, I agree with that. Yeah, if you could put like measurement marks and you could get a protractor that's the exact same size as a circle, you could measure that way. What we're going to do though is we're going to use a combination of angles and some other measurements and some other descriptive measurements from our circle to get our measurements that go around the circle. And what's nice about this is it's very similar to how we found the area of circles. It is very similar. I am recording this lesson, so if you guys need to go back and watch it later, you can. I'll post the blank notes with the video for you guys to look at. All right. Well, before we can talk about the length of arcs, okay, the distance between two endpoints, we need to talk about how we find the distance around the entire circle. And we call that the circumference. All right, and the circumference, there's two different ways to write the equation. Circumference equals diameter times pi, or the circumference equals 2 radius times pi. And that makes sense because the radius is half of a diameter. So 2r is the same thing as d. So if we're given the radius or the diameter, we have enough information to get the circumference, the distance around the circle. Now, you guys will see this as we move through the lesson today. Pi is one of those weird numbers. Okay, it's irrational. It's a decimal that goes on forever. So if we choose to leave our answer in decimal form, when we're talking about the distance around a circle, or an arc length, which is what our ultimate goal is today, if we choose to leave it in decimal form, we're not getting an exact answer. Our answer is going to be rounded. Okay, because pi can't be written as a decimal. I mean, it can, it just goes on forever. Okay, so a lot of times, if we want to leave answers as exact answers, we actually leave them in terms of pi. Okay? Because that leaves our answers exact. And there's some times that we need an exact answer. Okay. In case you're not sure or you forgot how pi is how they get pi. Pi is the ratio comparing the circumference of a circle to its diameter. Right? So it's the distance around the circle divided by the diameter. So the length of a diameter, there's about 3.1415 of those diameters that go around the circle. that's more of a reminder point than it is something you're gonna need. We're gonna be using more of these two equations in our arc length today. But this is how pi is a ratio, and it's a ratio of the circumference to the diameter. All right, so here's what we're gonna do. We're gonna start off by just finding the circumference. All right, we're gonna find the circumference of this circle that has a diameter of 12. We're gonna find it to the nearest tenth and in terms of pi. So here's how we find it to the nearest tenth. It's pretty straightforward. The circumference is diameter times pi. So we're gonna do 12 times pi. Well, if we want it as a decimal, we would multiply 12 times pi. And we get nearest tenth, 37.7.
And also like it's like half a circle, then you divide by 2 or something.
Yep. And you're on the right track because that's where we're going next, is we're gonna be talking about portions of a circle. If we want to leave it in terms of pi, or put it in terms of pi, this is even easier. You're done. 12 pi is the exact solution for the circumference. Okay, it's not rounded. This is exact, whereas 37.7 is, it's an estimated answer because we had to round it to the nearest tenth. Okay. In some regards, estimating is easier because I think it's this answer, if I'm thinking about a length in my head or a physical length, 37.7 is easier for me to think about and represent than 12 pi. Because in 12 pi, I gotta think, all right, 3 times 12 is about 36. I'm not sure what 0.14 is gonna add to that. So I would need a calculator. Did you take it outside when we went outside yesterday?
No.
There's one over there, but. I didn't see anybody that was looking for theirs this morning. I don't know. You may want to check the office, see if it's been turned in there. All right, here's another one, but this is a radius. Okay, they give us a radius here. So if we want to find this is why we use those two equations. Because we can say the circumference is 2 times the radius times pi. So that'd be 2 times 5 is 10, 10 times pi. I actually know this. It's going to be about 31.4. And in terms of pi, just going to be 10 pi. Okay. So, but again, it's good that we can do this both ways because there's going to be a lot of times we want to keep it in exact. So that's why we want to practice this in terms of pi. All right, here's one that let's talk about how we can represent this. Let's talk about how we can represent this as a decimal and how we can represent this in terms of pi. Okay, so our diameter is 16. So circumference equals 16 times pi. So as in terms of pi, it's just going to be 16 pi. In terms of a decimal, 50.3. Okay, so that's the full distance all the way around the circle. So what's halfway around? How would I find that? Yeah. And if we wrote 16 pi over 2, does that reduce?
Yep.
What's it reduced to?
8 pi.
Good. there's my exact distance that goes halfway around, 8 pi. Now I can do the same thing here, although I probably want to do 16 pi and then divide that by 2. And I'm going to get 25.1. Because if I rounded from here, I would have gotten 25.2 because it would have rounded up to, it would have been 25.15. So it's a good idea if you're going to do your halfway around, make sure you're doing it from your original 16 pi. Quarter way around, same process, right? We're dividing by 4 because 1/4 the way around is just a quarter. So we got our 16 pi over 4. Just going to be 4 pi. $12.6. And 1/8 of the way, so our 16 pi. 8. So 2 pi. .3. Okay. Now, we talked about this in like halfway around the circle, quarter way around the circle, and 1/8 of the way around the circle. Now we could have, instead of saying this, we could have said, instead of halfway around the circle, we could have said an arc with 180 degrees. Because that's halfway around the circle, or a semicircle. A quarter way around the circle, we could say an arc that measures 90 degrees. A 1/4 of the way, or sorry, an 1/8 of the way, that'd be an arc that measures 45 degrees. Okay, so we're actually finding the measurements of arcs here that have a specific degree amount. We just talk about them in terms of fractions of a circle. All right, so our arc length formula is going to be the degree of the arc over 360 times the circumference. And yes, this looks very familiar to our sector area, where we did the degree measure over 360 times the area of the circle. Right? All we're doing is we're taking the entire length of the circle around the circumference, and we're multiplying that by the portion of the circle that we need the length of. A lot of times we are going to be picking degree measures that end up being fairly clean looking fractions that can be reduced. It's actually really good practice for you guys moving into algebra 2 and pre-calc, because you're going to end up doing more trig when you get there. And algebra 2 trig is a lot different than geometry trig because it's all done within the coordinate plane. But you're going to be using a lot of these. You're going to be using a lot of these fractional measurements when you get down to the 2. Does everybody have this written down? All right. I'm sure we forgot the radius on this one. Make this one pretty straightforward. All right. So we'll make our radius 10. So we want to find the length of AB. We find that length to the nearest 10. All right, so our arc length equals the degree over 360 times the circumference. So I'm going to write out the whole equation. So arc length equals the degree measure 80 over 360 times the circumference, which in this case will be 2 times the radius times pi. Now, to the nearest 10, I could type this all into my calculator as is, and it'll pop up my answer exactly, or not exact, as a decimal, which I can then round to the nearest 10.
14, I think.
Exactly.
All around.
So 14.0.
13.96.
I concur, 13.9626, so that's gonna round it up to 14.0. There's my answer in there, 10. Now, in order to find your answer in terms of pi, if you guys remember, don't multiply pi in your equation then. All I want to do is multiply the 80 over 360 and the 2 times the 10. Okay, so I've got it written in my calculator. Right? I'm just gonna select that, but I'm gonna delete the pi part off. And it ends up giving me a fraction that's 40 over 9. Okay. Now typically you leave, because this is times pi then, because we didn't multiply times pi, you can either leave it like this, but a lot of times you see pi put in the top of the fraction. So like 40 pi over 9. Okay, either answer is correct. This is my exact answer. Now, a lot of times the fractions end up being a little cleaner than 40 over 9. And you'll see we'll use a lot of degree measures that are like 30, 60, 90, 45. Things that end up being in that like 1/4 range or the 1/3, 1/6 type range. Okay. So this length, 14.0 or 45 over 9. If you were to type 45 over 9 in your calculator, it will give you that 13.96 decimal that we got. It's just a simplified version. Let's do another. All right. Now this one, they want us to find arc ACB. And this is why you got to be careful with how the arcs are being named. We want to find the major arc. Well, in order to do that, we need to know what the major arcs. We need to know what the major arcs angle measure is. So if arc AB is 110, what's arc ACB going to be? Good. So this is 250 degrees. So we can write that now. So we got our arc length equals 250 over 360 times 2 times 5 times 5. So we plug that in. over 360 times 2 times 5 times 5. And I got 21.81 or 21.8 for my length. And in terms of pi, take pi out now this time. (125 over 18 pi) or 125 pi over. I actually think the examples you guys use on are going to be a little bit easier on the side. We'll finish off with this one. It says find arc AB to the nearest 10th. In this case, we're given an inscribed angle. Wow, the radiuses are missing on this. Tell you what, I'll make a copy of these slides after we finish them, so you guys have the radiuses on there. Because the copy that I made before class doesn't have it on. So AB we need to know what AB's arc length is, or arc measure is as a degree. It's not 58. 58 is the inscribed angle. So we have to double it. We get 116 for our arc degree measure. All right, so arc length is going to be 116 over 360 times 2 times 3 times pi. One 16, 2 times 3 times pi. 6.07, so that'll be 6.1. And in terms of pi, all right, 29 pi over 15. Now, if you guys, because I'm getting fraction answers when I'm plugging them in here because I'm typing the 116 over 360 as a fraction. If I didn't do that, if I typed it in as 116 over like divided by 360 in parentheses, it'd give me an answer as a decimal. Do you guys know how to convert your decimals into fractions on your red and yellow calculators? Okay, do that, okay? Don't leave your answer as a decimal times pi, because a lot of times that decimal is a decimal that goes on forever. So don't round your decimal and then put pi in there, okay? We want this to be exact, so get the fraction, okay? Make sure you're getting that fraction. If you're having trouble doing that when you guys are working on your assignment today, let me know so that I can help you convert those decimals into fractions. What's nice with these calculators, if you put it in a fraction to start off, it usually gives your answer in a fraction, which makes it a lot easier. Okay. All right, we do have some practice for you guys today.